All right, we're back. We're finally on page 10 of notes 12. Been quite the journey, mostly I think because of me having to do a lot of arithmetic. I'm not really sure. And find a lot like geometry. It's like finding all these areas. But anyway, let's see if we can do these. These are kind of random review-ish problems. So let's see. So the graph of f prime, the derivative of f of x with f of 0 equals -2, shown below. So I'm going to highlight that just in case we need it. So this is f prime. Put the following in order. All right. Well, we know f of 0 is -2, like for sure. So this is definitely -2. I can figure out the actual value of all of these, I think. So like this, for example, is going to be f of 0 plus the integral from 0 to 2 of f prime of x dx. So the integral from 0 to 2 is definitely 4. So that's going to be -2 plus 4, which is 2. So I'm going to count this as my explanation. Like I'm finding the values. Like it seems like a good explanation. This is going to be f of 0 and then minus the integral from -2 to 0 because you're going backwards. When you go forwards, you add the displacement. When you go backwards, you subtract the displacement of f prime of x dx. So this is going to be -2 minus the integral from -2 to 0 is 2. So -2 minus 2, which is -4. And then, I don't know, this is getting a little sloppy. So let's like highlight and make our work look colorful, I guess. I don't know. It's definitely not neater. Well, maybe it looks a little neater. And then f of -4, I'm going to say is going to, so f of -4, oh, we're not writing that. Okay, that's just going to be f of -2, and then we're going backwards, so the integral minus the integral from -4 to -2 of f prime of x dx. So our integrals always want to go from left to right. When we're going backwards, we subtract what we got when we went from left to right. So keep that in mind because I think it's an important idea. So -2 to 4, or -4 to -2, sorry, is going to be 3 by 2, so 6, but half of it, and negative because we're below. So -3. God, I don't know. Yeah, -3. So this will be -4 minus -3, -1. Okay, so what's our order? What color should we use? All right, so we got -4 is the smallest. So f of -2 is less than -1 is next. Nope, -2 is next. F of 0, which is less than -1, I think is next. F of -4, which is less than, what's the other one? F of 2. I believe this to be the order. I highlight this. This is my order. And what's my reasoning? I found all the values. I mean, that seems pretty compelling. So does it make sense? This is a relative minimum. You increase everywhere from here. So like the value should just keep getting bigger because the function is increasing. So wherever -2 is, every x value to the right of it should be bigger. And that turned out to be true. And then it's a relative minimum, which means that anything to the left of it should also be bigger. Like thinking about the original function, it should decrease until here and increase kind of like ever after and then decrease here. So I feel pretty good saying that this is bigger. And then the order, we kind of had to find the values to like really know. All right, I think that's good. Find and classify the critical points of f of x between -7 and 8. All right, critical points. Derivative is 0 or undefined in the domain of the function. Since the derivative exists everywhere, the function exists everywhere, so the domain is at least all reals between -7 and 8. So we have no places where the derivative doesn't exist. -6, -2, and 6 are our critical points, so let's write those down. F of x has critical points. I forget, -6, -2, and something. -6, -2, and 6. Okay, now when you write your explanation, you want to like group them so you don't have to write 3 explanations because we have going positive to negative, going positive to negative. Both of those are maximums. So -6 and 6 are relative maximums. So let's say f of x has relative maximums at x equals -6 and x equals 6 because f prime changes relative maximum, so it's got to be positive to negative. There. Okay, and then the other one, -2, it's not a bounce, so it's going to be a relative minimum because f prime goes negative to positive. So negative to positive, definitely going to be a relative minimum. So f of x has a relative minimum at x equals -2 because f prime of x changes negative to positive there. Negative to positive there. Seems so weird to just write there. How much we got to go here? Kind of a lot. All right, I'm gonna keep going, I guess. The secant line to f of x on the interval from 0 to 4. So the secant to f of x has a slope of 9/4. Find all values of c guaranteed by the mean value theorem on the interval. Okay, so the function is definitely differentiable because the derivative exists everywhere and therefore continuous. So the mean value theorem applies. I'm gonna write that. F of x is differentiable, which implies continuous. Therefore, MVT applies. Okay. So what does that tell us? That means that f prime of c equals f of 4 minus f of 0 over 4 minus 0, which actually we're just told is 9/4. 9/4 for some c, which is an element of 0 to 4. Okay, so between 0 and 4, f prime equals 9/4. Let's go to the graph. Between 0 and 4, excellent. Between 0 and 4, which is this interval, f prime equals 9/4 somewhere. 9/4 is 2.25. So I'm going to add that kind of to the graph. But so 2.25 is probably like here. So that'd be 9/4. So what we really need to do is we just need to find this intersection point. We find this, the x coordinate there is going to be the value of c. So what is the equation of this? This is 2 plus 1/2 the quantity x minus 2. So I just need to find where 2 plus 1/2 the quantity x minus 2 equals 9/4, and that'll give me c. Okay, so 2 plus the quantity 1/2 x minus 2 equals 9/4. Okay, 1/2 x minus 1 plus 2 is plus 1. Plus 9/4. So subtract 1 gives you, I don't know, 1/2 x. I was going to do it all in one shot, but then I got lost. So x is 5/2. Therefore, c is 5/2 because we're trying to find the values of c. Does that make sense? Yeah, that makes a lot of sense to me. I mean, it kind of looks like that was going to be the answer, but looks can be deceiving, and so you like kind of got to do the math. It makes sense to me though. Like I didn't draw it perfectly, and it looked pretty close. All right, a lot of review type stuff. I mean, the page promised to be review, so what are you going to do? But two options for this. We could say it's the displacement of f of x, so f of 4 minus f of 0. Or we could find f prime between 0 and 4, which maybe I don't want to do. Yeah, I definitely don't want to do that because it changes. Oh, well, this is f. What am I doing? Oh, the integral of, I'm super confused. I don't want to do what I was doing because this is the graph of f prime. I just want to find this area. So I'm going to say, should I erase this? Sad to see go, but so this and then this. All right, so 4 and then 4, 5, so 9. So I mean, this equals 9. So we do know that it should have just been 9 anyway, though. It's like 4 plus 5. So I wrote work that doesn't really match the work I did, but you were watching, so you understand, hopefully. Find f of 4 in 2 ways. Use information about the secant line. Interpret the definite integral from 0 to 4. I'm going to do this one first. So I know that f of 4, well, okay. I know, too far. 9. I know that the integral from 0 to 4 of f prime of x dx was equal to 9, which is f of 4 minus f of 0. So f of 4 is going to be f of 0 plus 9. And then f of 0, I assume, was given. F of 0 is -2. That was given. Okay, so f of 4 is -2 plus 9 is 7. That's one way. And then the second way, use the information about the secant line. So we know that f of 0, we know that the slope of the secant line is 9/4. And we know that f of 0 is -2. Okay, so we know that f of 4 minus f of 0 over 4 minus 0 is 9/4. So f of 4 minus f of 0 is 9. This feels very familiar. And then that was -2. So f of 4 is 9 minus 2 is 7. Got it both ways, so probably right. And then finally, solve for b. The integral from -7 to b of f prime of x dx is 0. Well, there's one answer I'm going to get out of the way right away, right? If you don't go anywhere, you get no displacement. So b could definitely equal -7. And now let's think. So -7 to b has to be 0. I think we're going to accumulate some areas. So -7 to b. Ah, man. All right. -7 to -7 definitely works. This area and this area are just going to cancel out. So b could also be -5. -7 to -5 definitely works. So -7 to -5. B equals -5. Okay. And now we got to work for it. So what I need to do, basically, first I need to erase some stuff. So let's get out of my way, all of you. Everything must go. Okay, so I know that I'm going to shade these. This area and this area are just going to cancel, right? So like starting over at -5, I'm going to start getting more negative values because I'm accumulating negative area. So this is, can I find this? It's not a triangle. What do I want to do here? Oh, I'm going to do, geez. Okay, 1, 2, it's -2. And then this is 2 by 3 is 6, so -3, so -5. All right, so that's -5. So if I start here and I go -7 to -7 is 0, -7 to -5 is 0, -7 to -2 is going to give me -5 because I've accumulated -5. So I just need to accumulate +5 and I'll be done. When do I get to +5? Well, this is 2. And then this is another, this whole thing would be 4. So I just need 3 of them. So I just need to go here. This will give me 3. So I think that if I go to 1.5, and that's, it doesn't say it should work, so I'm not going to. Because I think we talked about it, and I think that's good. I mean, you could, I guess, you do -7 to -7 of f prime of x dx is 0, -7 to -5. I mean, this seems dumb, but it's better work than no work. And then -7 to 1.5 of f prime of x dx is also 0. They're all 0. So there's 3 answers. The one that almost everybody forgets, I forget a lot, is this one. It's a trick. It's kind of a trick answer, but it's like definitely an answer. All right, we're done. Woo! So I'm gonna end this here. I will be back in the next video, I guess in notes 13, because that would be the next thing to do. So I'll see you there.